In this video I'm going to show you how you can come up with the equation of a straight line that passes through a particle moving along the y equals x squared graph, and it has to pass through this precise point 1, 2. So for example, let me illustrate it. So as the particle moves along the y equals x squared, so y equals x squared is this line here, and see this particle here. As you move it about, it will always draw a straight line from the particle to our point 1, 2. Okay, so first step, punch in your quadratic y equals x squared, punch in your point 1, 2, and then punch in your particle, which is this thing here. And then now in this video I'm going to show you why the equation is given by this. Okay, so going back to here. So to come up with the equation of this straight line, well, this is a straight line, so it's going to be of the form y equals mx plus c. Your job is to find the gradient and the intercept. So what is a gradient? Well, imagine, by the way, this diagram is not drawn to scale, but imagine this is 3, then this will be 3 squared, because you would put the 3 into here, and then when you square it, it would be 9. So this here would be 9. So if this point is at A, then the height must be a squared, because you would put the A into the x, square it, and then it will jump to the quadratic. So this point here is a squared. So to work out the gradient, you need to know the height divided by the across. Well, what's the height? What's this height? Oops. What's this height here? Well, this height here would be from here, and then you take away this bit here. So hang on. So the height, so this height here, hang on, let me erase this. So this height here will be given by this height, which is a squared, and then you take away this height here. Well, this height here is the same as this, which is 2. So you take away 2, and then you divide it by the across. What's the across? Well, the across would be this whole length here, which is a, and then you take away this length here, which is 1. So it would be a take away 1. Okay, so let's start again here. We need to know the gradient. The gradient would be this height divided by this length. So the height would be a squared, take away this height here, which is 2, and then you divide it by this length. Well, what is this length? It would be a take away this length here, which is 1. So the gradient is given by this. So we can put this into the m. So our current straight line is given by this. This is our gradient. We still need to work out c. So to work out c, we need to select one point on a line. So to work out c, we will need one point on that line. We could select this point or this point, because to work out the intercept, we need one point on this straight line. So we select the easiest of the two. We could select this one, or we could select this one. So let's select the easiest of the two, which happens to be this. So this is your x, this is your y. So put this into the y, put this into the x. So put the 2 into the y, put the 1 into the x, and then work backwards to find c. So when you put 2 into the y, it will then become this. Put 1 into the x, and then 1 times this block will be this block. So now we can work out c. So at the moment you've got 3 blocks, 1, 2, 3. So now take away this block from both sides. That will then give you this. So c is given by this. This whole block here is c. So we can now put it back into here. So this equation will then become this. So now you can see that this is our gradient, which was m, and our intercept, our c, is given by this thing here. So punch this whole thing into Desmos, and then it will then punch a whole thing into Desmos, it will then give you this thing here, and then as you slide your particle around, it will draw a straight line going through the particle and our point 1, 2. Even if you take it into the negative, it will still work. Okay, so try it out for yourself.